Hello, today we are going to look at the distance between 2 points, and we're going to be dealing with them on our coordinate plane, or sometimes called our Cartesian plane, where we have our x coordinates going side to side and our y coordinates going up and down, and we remember which one is which because y is longer up and down than x is, so it's the up and down measurement. Now, if we want to get the distance between 2 points, we need to know what the coordinates of those points are. So first job is, if I want to know the distance between the points A and B, I have to know what the point A is, where it is, and where the point B is. So as always, to get my coordinates, I start at the origin, I start at 0, 0, and then I am going to go in the door until I'm underneath my point A, and that gets me to 6. So I go in the door 6 and up the stairs 11. So A is at in the door 6, up the stairs 11. And B is at start at the origin, in the door 10 and up the stairs 11. So in the door 10, up the stairs 11. And that's my 2 points. So I now know where A and B are, so I can figure out what the distance between them is. Now, for more complicated questions, we're going to use this formula, and it's going to be on page 18 in our log tables. And for all of this chapter, we're going to need to have page 18 in our log tables open. It's impossible to do this chapter without having the log tables open on page 18. So we have our distance formula, and we're going to use that in a little minute, but first of all we are going to do some simpler cases because they come up in the exams, and if we can save ourselves from having to use a complicated formula, we should. So what's unusual about these two? Well, we can see that they are at the same height. They have the same y value. They're just straight across from each other. If we look at the grid, they're not crossing any grid lines. They're just going, they're not diagonally across from each other on any grid lines. They go straight horizontally across from each other. And we can see that in our coordinates because the y coordinate is the same. They're both 11. So the only thing that has changed is we started at x is 6 and we've gone over to x is 10. So then the distance between those 2 points is just going to be the difference between 6 and 10, which is just going to be 4. So if I count this over on my diagram, each one of these boxes is 1. So I go 1, 2, 3, 4 places over. And mathematically, we could write that as the distance from A to B is equal to 10 minus 6 is equal to 4. And we could write in units there because it's a measurement. We don't know what we are measuring in here. We aren't told, but we should put in units if we remember to do so for our distances or our lengths. Now, I've just said that this is the distance between A and B, and this is a symbol or a way of writing we need to be sure that we're familiar with. So A and B are our points that we're talking about, and we use capital letters for our points. And then we say we want the length between these two things, between these 2 points, by putting 2 vertical lines on the outside of A and B. So this is an important thing and we need to know it for our exams. This means distance or length between A and B. So if we're asked for the length between A and B, or the distance between the points A and B, then we're going to use this symbol here, or they could give us that symbol in the exam. So we have to be very clear, as the note I've given you here, the distance between the points P and Q would be written as our 2 vertical lines around capital P and capital Q. And this is an important thing you can see I've done for all of the questions we've got here. So we are going to continue on now to our distance between A and C. So again, we need to know what the points A and C are. That's our first job. So we have A is at in the door 6, up the stairs 11. And C is at in the door 6, up the stairs 5. C is at in the door 6, up the stairs 5. Now, what's unusual about these ones in terms of distance is our x coordinates are the same this time. So again, this is a special case where we don't need our fancy formula. We are going to use it in a minute, but what we have right here is easier to do just by looking at our graph or by noticing that all that's changed is we have gone from 11 to 5. So how many places have we moved? We have gone 6 places. And we can see that on our diagram. We go 1, 2, 3, 4, 5, 6 blocks, and these are counting in units. So we have gone 6 units from A to C. And we can count that because we're just going along one of our grid lines, counting directly from A to C. Because our x coordinate is the same, that's how we would spot that we are able to do this. Just like our y coordinate was the same and we were able to do it going straight across from A to B. So our distance then, remember we use distance as our vertical lines around our points, is equal to 11 minus 5. Now we don't tend to deal with negative lengths. So we are imagining that we're putting a ruler to this effectively. We wouldn't get a negative number from our ruler. So for lengths, we're not going to worry about negative numbers. We're always going to try and get a positive value for our lengths. And we're going to write in units if we don't know exactly what unit we're dealing with. Then we're going to look at the distance from D to E. And again, I can see that they're directly above and below each other. So this is going to be very similar to what we just did with A and C, but we need to get our coordinates first. So we go start at the origin, in the door -1, up the stairs 4 for D. In the door -1, up the stairs 4 for D. And then for E, we go in the door -1, and up the stairs, or down the stairs as you like, -5. So I can see that my x coordinates are the same. So all I need to do is find the difference between the y coordinates. But I need to be careful here because I've got minus numbers going on and I have to get the difference between them. So I can do this on the graph to give me some confidence as to what answer I should end up with. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm expecting my answer to be 9, and I want to get the difference between my distances. So I'm going to minus them from each other. So I get the distance between D and E is going to be 4 minus -5. Minus 5 is going to be plus. So minus by a minus multiplied by a minus is going to be a plus, and 4 plus 5 is 9. And we say units for our lengths or our distances. Now, that's the simpler situation, but we have to be able to deal with more complicated situations too. So now we're going to have a look at how we do our formula. So if we want to know the distance from C to B, what have we got to do? Well, we need to know what C is. So C is start at the origin, in the door 6, up the stairs 5. 6, 5. And then B is at in the door 10, up the stairs 11. And this is going to be our first point. So I'm going to call this our first x value and our first y value. And B is going to be have our second x value and our second y value. So that's what, it does not actually matter which one of these you pick as being first. So if you picked B as being your first point, that would be fine as well. Now, this is a formula, so we're going to write down our formula. So CB is going to equal, it's the formula here, it's on page 18 in our log tables, and we need to have page 18 in our log tables open for keeping track of this. We get the difference between our x values. This is effectively building off of what we just did. To be squared plus y2 minus y1 to be squared. And we're always going to write that down, always going to write down our points, label them x1, y1, x2, y2, and then sub into our formula. So anywhere there is an x2 in my formula, I need to put 10 in brackets. Whenever we sub in, we always put in brackets. Minus x1 is 6. Plus y2 is 11. Minus y1 is 5. To be squared. And we can put all of that in the calculator, but it's a little bit safer to work out the brackets first. So we have 10 minus 6 is 4 to be squared, plus 11 minus 5 is 6 to be squared. And we can put all of that in the calculator, and we get, from our calculator, we get 2 root 13, and that would be an answer in surd form, or often we'll be asked to give our answer to 2 decimal places. So in this case, the 2 decimal places would be 7.21, and we would say units. So this is what's called a surd, where we leave the square root thing in it. And this would be to 2 decimal places, which would be more common for the exams, but we can get either. Now let's go through that process again for getting the distance from A to D. So we need to know where A is. We go in the door 6, up the stairs 11. And for D, we go in the door -1, up the stairs 4. And then we write down our formula. I'm going to write that for you now. So we have our formula written down, and I have labeled x1, y1, x2, y2 for my first point A and my second point D. And now I'm going to sub into that. So anywhere there's an x2, I have to write in -1. We can see now we have a negative number, so it's very important we put that in brackets so we don't make any mistakes. And then minus 6 to be squared, plus y2 is 4, minus y1 is 11 to be squared. We tidy that up a little bit before we put it all into the calculator, or to help us not make a mistake. So we have -1 minus 6 is going to be minus 7 to be squared, and 4 minus 11 is 7, or sorry, -7. And that's in brackets. So then we can put all of that into the calculator, and we get 7 root 2. Now we be careful, we have to put everything in the brackets as I'm writing it here, or we will get the wrong answer. So be very careful with your brackets when we use this formula. And then we could be, that's it in surd form, or we could be asked for it to 2 decimal places. And in this case, that would be 9.90. And again, units, because we're dealing with a length. So we could be dealing with centimeters or meters, or so on. Now, just a very quick final note to mention it to you. This formula is the same as Pythagoras. So when we're doing our right angle triangle work, I'm going to draw one in for you here for CB. What I've done is draw in the line segment CB, and then the length of that is the hypotenuse of a right angle triangle with a height of y2 minus y1 and a base of x2 minus x1. And if we can link that together in our minds, that would be great for connecting our trigonometry to our geometry. But this is the really important stuff for now.